Yeah, the project I'll be talking about today is the Magic Valley Origin Destination Study. It's something that we're in the progress of working on for the Idaho Department of Transportation. And basically what the project is, it's just understanding travel patterns in the region with the purpose of evaluating and identifying potential new river crossings over the Snake River Valley. So today I'll just be presenting a little bit of background about the study so we all understand what's going on. And then specifically talk about how StreetLight was used in the analysis, talk about some of the next steps, and then open up the floor for questions. So I'll be giving this presentation, and then Yi-Min is also on the call. He did a lot of the actual StreetLight analysis, so he'll be here as backup for any especially challenging questions. So I'll talk a little bit about the geography of the study since it's pretty important to what we're looking at. The study area itself, the Magic Valley, is located in south central Idaho, so kind of centered around the Twin Falls area, about 2 hours away from Boise to the west and about 3 to 4 hours from Salt Lake City to the east. The area is predominantly agricultural, and there are three main things I want to highlight about the study area that were important to what we were looking at. So the first one is the Snake River, which is that blue ribbon going from east to west across the map. And south of that river is Twin Falls, which is kind of the main commercial and industrial center of the Magic Valley with about 50,000 people. And then to the north of the river is Interstate 84, which really provides the key connections to Boise to the west, and then to eastern Idaho and Salt Lake City to the east. Currently, there are really only two main crossings that allow access between Twin Falls and I-84. So the main one is that orange dot directly above Twin Falls. That's the US 93 crossing, and really what we're focusing a lot of the study on, because that's the primary connection to I-84, especially if you're trying to get to the Boise area. And the second is State Highway 50 to the east, which is also provides a fairly direct connection to I-84, especially if you're going out east to Salt Lake City. So the purpose of the study was to, again, understand regional travel patterns and OD characteristics with the intent of using that data to test the effects of new Snake River crossing locations. So to talk about some of the constraints and why we're looking at a new crossing, I want to explain some background. Just south of that main crossing, north of the city, it's probably the highest commercial center, highest concentration of commercial uses in south central Idaho. So there's a Costco, there's a mall, and really just limited opportunities to expand capacity in this area. It's getting pretty congested and just limited right-of-way opportunities, especially since it's right up against the Snake River Gorge. The Snake River Gorge itself is a huge topographical constraint. So this just kind of helps illustrate that a little bit. It's about 500 feet from the bridge. So this is that bridge just north of Twin Falls down to the actual river. The area was made famous by Evel Knievel back in the 1970s, who actually attempted to jump over this river via a motorcycle rocket ship. It's also the only man-made structure in the United States that allows base jumping without a permit. So just a couple of fun tidbits about the area to demonstrate, just how the magnitude of looking at a new river crossing in this area. So like any other kind of high investment capital project, there are a lot of considerations that would need to go into a new river crossing. So cost, for one, is a big one. There are environmental considerations, constructability, safety, et cetera, et cetera. We looked at all of these a little bit in the study, but really what we were interested in was travel patterns. What crossing, just from a traffic demand perspective, would provide the most benefit to the region. So we looked at 5 different crossings. One of them was just widening an existing crossing. And then we wanted to evaluate the effects of 4 different crossings and what that would have on travel patterns in the region. So we consolidated from a lot of different data sources. We did our kind of typical highway capacity manual, traffic operations analysis, identifying key areas of congestion in the region. So you can see right here, right below the main crossing, that's kind of all that red, that's where most of the congestion is. So conveniently, the area that the most critical connection to the city is also the most congested. So this was kind of the first step of our analysis. And then another data source that we really relied on was ITD's statewide travel demand model. So they have a statewide travel demand model, and it's really useful for looking at regional connections in the area. And we used it to model each of our river crossing options. So that's what you see, this big red here. That's one of the river crossing options we were looking at. The travel demand model, it can tell us a lot of stuff. It can tell us, what's kind of the approximate demand for new crossing. It can look at scenarios with changes in land use. So in our case, we were looking at year 2040. And it can also tell us the effect that these crossings and these new alignments have on regional traffic patterns. However, there are a couple key limitations. Travel demand models, they only allow for so much granularity, especially when we're not the ones owning and maintaining the model. And it just has limited opportunities of looking at, OD characteristics in the neighborhood, because it's not really rooted as much in real world data. It's a model and it's calibrated with the data, but it's not it's a model, and it has its own algorithms that kind of controls how travel patterns are determined. And then another key limitation for us in this study is it also had a limited freight component. So that kind of tees up to how StreetLight fit in to this project and why we thought it was important for this analysis. And a quote that my colleague Yi-Min gave me is, why model when you can measure? So we wanted to bring in StreetLight really just for some ground truthing and some real world validation of the other data that we were using to determine the effects of travel patterns that a new river crossing would have. So we compiled a lot of this data, and then we brought in our origin destination findings to really just ground truth and validate our findings and recommendations. So next, I'm just going to go through our OD analysis and just highlight how we used it in this analysis and some of the findings that we brought away from it. So we found that StreetLight really provided a good way to generalize the data. So the first step that we took when we got the StreetLight data, we kind of divided our study area into 4 general zones. And just looked at overall travel patterns and said, all right, between these 4 quadrants, for all the traffic going over the bridge north of the crossing, where is it going? And you can see from what we're looking at here in this graphic, it primarily served traffic to the west. So this is just our first general look, and it gave us a gauge on general demand in the region for a new river crossing. On the flip side, so StreetLight was great for kind of generalizing this travel data. We also found it was good for analyzing a set of concise granular zones. So in this case, we wanted to see how much of the traffic going over the US 93 bridge actually was the destination or the origin was kind of in that commercial area just south of US 93, because we consider that traffic that was unlikely to shift to a new crossing if that was provided, just because US 93 would still be, in most cases, the most direct route. So in that case, we found about 56% was likely to stay at US 93 regardless of where the other crossing was located. And then another useful thing that we found StreetLight data in our analysis was the use of gate zones combined with kind of aerial zones. So in this case, for this analysis, we had 2 what we call gate zones over the 2 river crossings. And we wanted to see, out of all the traffic leaving Twin Falls, what % utilized which zones when they were going on I-84 to the west and to the east. So here we found that, kind of as expected, the majority of traffic going to the west used the direct crossing just north of Twin Falls, while traffic to the east was actually split between the 2 crossings. So that was an interesting finding. And then we wanted to dig a little deeper and see how freight was using these crossings. So, and this was pretty interesting compared to the last slide. So we actually found in this area, this industrial area south of Twin Falls, where there's a lot of industrial uses, that freight traffic that went on I-84 west, actually about a third of it chose the less direct route and went to the east on State Highway 50. You can see that 35%, and then went on I-84 west. And I found this to be an interesting finding because I know through past planning studies, we had stakeholders and agencies kind of tell us this stuff. They're like, yeah, freight bypasses US 93, but it was all anecdotal. So it was nice just to see some kind of real world data validation for these findings. And we found this really useful to differentiate between freight and normal vehicle traffic. So those were some of our key origin destination findings. And now in the study, we compiled the results for each option, looking at PM peak hour demand, change in travel times, infrastructure, even came up with some cost estimates for these river crossing options. We presented them to ITD and some stakeholders, and it's a project that really garnered some interest in the region. We had a couple articles about it, which was exciting. So currently, we're just wrapping up some final documentation with ITD, and we're excited to have future conversations about river crossing strategies in the region.